Hi, good afternoon. We are a team of Omnidirectional Owing robot. In this kind of project, we are trying to find the solution about the problematic of the lack of food. There is some methods that the farmers can do to do their job, but in this side, we try to find another way to make them more easy their job in like this kind of a kind of robot able to make easier their job or well the farming part of that work. Now my classmate Ricardo is going to explain about more about the robot.
Well, according to the UNES Food and Agricultural Organization, FAO, agricultural production needs to be increased in 70% in order to meet the food demanded in the 2050. So this project is focused on the smart farming, that is precision agriculture for a more sustainable world. The objective for the robot is to increase the production and reduce the human factor in agriculture. So this will be carried out by an autonomous omnidirectional mobile robot capable to plant seeds used from the food production using sensors, camera, and navigation system. Worth mentioned that currently there are some kind of similar automatic seed sowing robots, but our goal is to do it with more accuracy, speed, and obviously with an autonomous robot. That is the point of this project. All of this is thinking about the future, the population increase, and the food required in the following years.
So in the methodology, the prototype will consist of an omnidirectional platform with sensors and actuators such as webcam, moisture sensor, zip disper, ultrasonic sensor, light sensor, will be great design and controlled using CAD, that is computer aided design. So software for the realization of some parts such as the chassis, wheels, and the other complements. And of course, the robot will be controlled by a Raspberry Pi 3 Model B, taking advantage of the processor, ports, and connectivity to some peripheral it has. This will be done thanks to the RTOS, right-time operation system using ROS as a framework or environment for controlling low-level device, tracking hardware and communication between nodes.
Now for the results, the expected results of this robot is to increase food production with high performance, with the idea of improving the way of how the task is done in planting different seeds in a more autonomous way, where performing the task faster and more accurate in the orchards of farms and even for people who want to sow in their homes. Some other things we need to consider is how agricultural robots will be more necessary in the food production and its demand in the market.
Finally, in conclusion, in this project, an autonomous omnidirectional showing robot will be performed using real-time operation system for their control, getting more accuracy and performance than other existing showing robots. This robot is expected to increase the productivity to generate food required in the following years. This kind of robot will have an increment of demand as we show in the graph 1 of, as you can see in the image, agricultural robot revenue and exports. This means that agricultural robots will be required for human being in the next years.